Today we are going to analyze the motion of off-ice axel jump. First of all, let's watch the video about off-ice axel jump produced by Wayne and Cash, who represents the professional and the beginners. To make sure we can analyze the motion more accurately, there are two angles for the video. One is side angle and the other is front angle. To unify our measurements, in the following results, the statement scale of the images to reality will be 3 cm to 100 cm. As you can see on the left photo is in reality measurements, which is 100 cm between two cones. On the other hand, the photo on the right side is in ruler measurement, which is 3 cm between two cones.
Now we are going to talk about the straight length and velocity of Wayne and Cash. We will start with looking at Wayne's straight length. We are using ruler measurement to measure the length of Wayne's step. The first step of Wayne is 2.5 cm. The second step is 2.8 cm, and the last step before takeoff is 3.5 cm. Besides, the first step of Cash is 2.7 cm, the second step is 4.3 cm, and the last step before takeoff is 3.1 cm. To commence with, let's talk about the velocity and straight length in the reality measurement of Wayne. His starting time, which is recorded since his front leg angle left the floor, is 2.766 seconds, and the ending time record in the second that he completed his jump and finished the recovery pose is 5.733 seconds. The total time he spent on the motion is 2.967 seconds. The displacement traveled combined by the first three strings and jumping displacements is 400 cm. Therefore, the velocity of the full motion can be calculated by the displacement over time, which is 134.82 cm per second. Next, the first straight length of Wayne is 83.3 cm. The second is 93.3 cm, and the third is 116.7 cm. So the average straight length will calculate for Wayne is 97.77 cm. And here is all the data we collect from the video and the calculation steps. Here is the calculation of Cash straight steps and velocity. The starting time of him is 2.766 seconds, and the ending time is 5.366 seconds. The time spent was 2.6 seconds. The displacement is also 400 cm, while the ending point is on the last cone. After the calculation, the velocity of Cash is 153.85 cm per second. Here we can see that the first straight length of Cash is 90 cm, the second is 143.3 cm, and the third is 103.3 cm. Finally, the average straight length is 112.2 cm. And here is all the data we collected from the video and the calculation steps.
Now, we are going to analyze the two postures made by Wayne and Cash of the off-ice axel jump while taking off in the air and landing. Firstly, let us begin with the takeoff position. Comparing the two pictures taken from the front angle, we could see that Cash takeoff is different from Wayne's. The trunk and the shoulders position should always face forward before the turn, while the takeoff feet should also point forward. In the photo, we can see that the trunk, shoulder, and feet of Cash all pointed in the wrong direction. That may affect the height of the jump, and it also would easily lose his balance. Then, the photo here, taken from the side angle, is showing the air positioning during the takeoff stage. We can see that Wayne's leg lifts away from his body's medial line, as it helps to throw the momentum out to forward. Basically, it can help to build the flow for the turn, while Cash sticks his leg too close, and so it cannot bring out the innate quality of the jump.
Next, doing the rotation in the air needs a lot of techniques. Before doing the rotation, leg roll crossing is one of the most important key. The photo here shows the air positioning before crossing the leg. Wayne's left foot in the front and getting ready to cross on top of the right foot. But Cash's right foot remains in a lift-up position, which leads to a lack of space for the left foot to cross on top. This posture leads to different outcomes for the spinning process. As we can see at the left-hand side of the photo, Wayne's left leg has already crossed on top of his right leg tightly, while Cash's two legs have split up. This affects the spinning quality, as Wayne can spin more than one rotation during the air, where the Cash cannot. Besides, the photo of the air positioning taken in the front angle shows the different arm position between the two of them. Wayne's both arms are tied together in front of the chest while spinning, but mine are separated. Due to the rotation made around the central median line, could increase the speed of spinning. So, if the arms are tightened up to the chest, that the whole body is close to the imaginary line, greater performance would be seen. The left-hand side of the photo, we can see that Wayne's whole trunk is more close to the median line while turning, and he is also remaining symmetry during the spin. On the contrary, Cash's trunk is more far from the median line while turning, and we measure that his trunk is 9-degree tilt to the right. This leads to different outcomes, as Wayne can spin more than 360 degrees, which is around 1.5 revolution, but Cash only can spin less than 316 degrees, which is around 1 revolution at a time.
So let's study the foot landing position. We can see that it has obvious differences, which one of them land backwards while one of them land forwards. The landing direction strongly affects the ending posture. We can see that Wayne has a balanced ending posture with two arms wide open and standing with one leg facing backwards. Oppositely, Cash lost his balance while landing, making him can't even finish his ending pose. The above shows the detail of the posture made by both of them, brings out a large contrast of the flight time during the rotation in the air. To make a better comparison, here is the calculation of their flight time. The takeoff time of Wayne is 4.633 seconds and land in the 5.166 seconds. His total flight time is 0.533 seconds. The angular velocity is 2.81 revolution per second. Compared to Cash's results, he made a jump with 0.467 seconds of flight time, while his angular velocity is 2.14 revolution per second.
Last but not least, let's talk about the highest point and the takeoff angle. In the following photos, the number of data shown in black represents the measurements of the ruler, On the other hand, the green numbers represent the reality measurements of the data. This is Wayne in the photo. The calculation of the highest point is alpha equals 3 cm over 100 divided by 5.5 cm, which is 183.33 cm in total. The calculation of the highest point of cache is alpha equals 3 cm over 100 divided by 5 cm, which is 166.67 cm in total. And for the calculation of the takeoff height, it is alpha equals 3 cm over 100 divided by 3.4 cm equals to 113.3 cm. For the takeoff height of cache, it is alpha equals 3 cm over 100 and divided by 3.3 cm equals to 110 cm in total. We use a plumber to measure the takeoff angle in this photo, and Wayne's takeoff angle is 41.8 degrees. And then we measured the takeoff angle of cache is 31.5 degrees. To sum up the data of the slides above, you can see in the table, subtracting the highest point and the takeoff height, we can find out the vertical distance traveled. Wayne's result in 70.03 centimeters, but cache only results in 56.67 centimeters.
Based on the data we've mentioned, we can compare the velocity and stride length between Wayne and cache. Cache results are larger than Wayne's, but the flight time and the angular velocity of Wayne is more longer and larger than cache. Also, Wayne vertical distance traveled and the takeoff angle are more far and larger than cache. So, how can cache perform the off-ice axel jump in a better way? Here we have planned a program combined with 4 exercises for cache to improve his performance.
First exercise, a stimulated takeoff and landing position. On the exercise, we simply do the takeoff and landing positions back and forth 5 times in a row each. At first, we will straighten up the body and bend both knees while the knees are pointing forward. Then, lift up the right foot to the back. And we want to be sure that the left foot is stable but not shaky. Then, hold this position and stand up with the left foot as 1 repetition of this exercise is performed. The chest and the knees should be facing forward but not pointing in the other direction. And be cautioned that the head should be looking forward but not looking at the ground. Right foot will put at the back side of the body and stay bent.
The second exercise is 2-foot vertical jump with arm swing. The aim of this exercise is to coordinate while takeoff, to help sense the balance during the air and landing, and also to learn and get used to release time at takeoff with the exit of the arms, and to bring up higher points during jump. And the remark is to stand still and relax arms before jump. Bend knees to jump. The third is swing arms from back to forward until the chest level. Finally, is to the both power from the swing and takeoff should perform at the same time.
The third exercise, doing half rotation jump with single leg takeoff. It is a practice to feel the transferring of the center of gravity from left foot to right foot. Be sure that take off with left foot and point forward, and the landing should be facing back to the takeoff point after rotate 180 degrees, with right foot pointing the direction of takeoff. For the landing, we simply stand still with both arms held up to chest level, and pull up the left foot and point the back side of the body. Then, bend the right knee at 1 repetition of the exercise. We will do 5 times as 1 set. This exercise helps to strengthen the core muscle with increased the stability of takeoff, air position, and landing.
Exercise 4. 2-foot vertical jump with arms close to chest level and single leg landing. So, first we'll stand still and relax our arms. When we are ready and enter to jump vertically, we'll bend our knee to jump, while at the same time swing our arms from back to forward until to the chest level. The ideal push-off time should be the time when using both power from the swing and the take off by the foot at the same time, instead of swing first then follow up by jump, or take off and then swing. And we'll finish up the landing by using our right leg to bend and the left foot pointing at back, as one complete repetition of this exercise. We'll do 10 reps in total. This exercise aims to help the coordination while takeoff, as well as the balance during the air and landing. This is also a fundamental exercise to many jumping skills, since it requires athletes to learn and get used to the release time at takeoff with the assist of the arms to bring up higher in the jump.
In conclusion, we hope that after the beginners follow the program we planned, they can learn to hold the right position for jumping in the air and rotate the correct axis of rotation. Also, they can know how to rotate faster and better body coordination during takeoff throughout the exercise process. Moreover, they can strengthen the core muscle and build up stability of jump, as well as balancing when landing. And this is the end of our presentation. If you have any question, you can ask now.